Assalamualaikum and selamat sejahtera to Dr. Fauzi bin Baharudin. Welcome to our presentation video. We are going to show you some experiments for our topic, which is properties of fluid. Before we start our presentation, let us introduce ourselves first.
My name is Fatil Elisa. First of all, I am going to talk about the introduction. Alright, let's get started by understanding the basics. What exactly are fluid properties and why do they matter? Every fluid, whether it's water, oil, air or even lava, has its own unique personality. And just like people, we understand fluids by looking at their characteristics. These characteristics come from what they are made of, their composition and how their molecules are arranged or their structure. Now, to make things easier, we can group fluid properties into three main categories. Let me walk you through them. First, we have thermodynamic properties. These sound a bit heavy, but it's really about things like temperature, pressure, density, and surface tension. These properties helps us understand the state of the fluid, like whether it's hot or cold, how tightly packed the molecules are, or how much force it takes to break the surface. Think of surface tension. For example, that's what lets insects walk on water. It might look like magic, but it's all thermodynamics at work. Second, we've got the kinematic properties. These are about the motion of the fluid, how fast it's moving and how the movement is changing. The key players here are velocity and acceleration. For example, when you turn on a tap and the water speeds up as it flows down, that's acceleration. Engineers and scientists use these properties to model fluid flow, whether it's blood in arteries or fuel in a rocket engine. And finally, we have the physical properties. These are the simple observable characteristics like color, odor, or whether the fluid is transparent or cloudy. These might seem basic, but they are really important, especially in industries like food, cosmetics, and medicine, where the appearance and smell matter a lot. There are three types of properties in fluid. In this project, we are conducting these experiments, which is density, viscosity, and capillary.
Density refers to how much water is packed into a substance, and it usually measured in gram per cubic centimeter. Every liquid has a density. In liquid, density determines if a substance will float or sink in a particular liquid. Hi, my name is Afina. So today I'm going to do the density of the experiment. So basically, density to measure how much matter occupies a given amount of space. So for this experiment, we're going to use a beaker, a water, a dishwasher, and the oil. So to conduct the experiment, we're going to fill the beaker with the water. Next, we're going to add some oil. And lastly, we're going to add some dishwasher. And then we're going to leave it for 50 minutes. 50 minutes, we can see the liquid separate out. as a dishwasher, it has a highest density, so it sits in the bottom. For the oil, has a lowest density, so it raise up.
My name is Irma Zakwan bin Zuleka. My ID number is 2024 24 94 84. Viscosity is a measure of how thick or sticky a liquid is and how easily it flows. Liquids with high viscosity like honey or syrup are thick and flow slowly because they resist movement. On the other hand, liquid with low viscosity like water or juice are thin and flow quickly and easily. In simple terms, viscosity describes how much a liquid resists flowing. The higher the viscosity, the slower it. To carry out this experiment, these are the apparatus that I'm going to use, which is vernier caliper, ball bearing, measuring cylinder, and 3 types of liquid, which is dishwasher, oil, and water. First, pour the water that has been measured into measuring cylinder. Then, drop the ball and it takes only 0.29 seconds to reach bottom, which means the water has low resistance and allows it to fall quickly. Next, by doing the same step but with cooking oil, drop the ball but this time it falls even faster in 0.18 seconds. This means the oil we use is less viscous than water, so it gives less resistance. Finally, doing the same step but this time, pour the dishwasher at measuring cylinder. Then, drop the ball bearing into the dishwasher while taking the time of ball bearing falling from top to bottom. As seen here, the ball moves slower than both water and oil, indicating a higher viscosity. These are the result of the viscosity experiment. As we can see that the water and dishwasher has the higher viscosity, with the time taken are 0.29 second and 1.91 second than oil, which is 0.18 second. Even though oil is usually has higher viscosity than water, but in this experiment, the ball fell slower in water. This might be because the ball floated more in water. The result could also be affected by the liquid's temperature or timing errors.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Fadli bin Rosli. ID number 2024404322. Capillary is the tendency of a liquid in a capillary tube to rise or fall as a result of surface tension. The narrower the capillary tube, the higher the water level rise in the capillary tube. All liquids have cohesive properties, because of which all the molecules tend to stay together. This will create surface tension. To carry out the experiment, firstly we need a dishwasher, second we need oil, and third we need 3 type of straw with different diameter and sizes, and lastly we need a measuring cylinder. Okay, first of all, fill the beaker with 250 ml of water. Then, put the 3 straws in the beaker without touching the bottom of the beaker. Maintain it for about 30 seconds. After 30 seconds, we will see the narrower the diameter of the straw, the higher the water level. After that, we replace with oil and also repeat the same step. We replace the water with soap. Repeat the same step.
In this experiment, we can observe some interesting relationships between different fluid properties. First, let's look at the relationship between viscosity and density. In liquids, as density increases, viscosity also increases. That means denser liquids tend to flow more slowly, like how honey is thicker than water. But in gases, it's the opposite. As density increases, viscosity decreases. This is because the movement of gas molecules works differently than in liquids. Next, we have the relationship between pressure and velocity. These two are inversely related. When pressure increases, velocity decreases, and vice versa. This is explained by Bernoulli's principle, which says the total energy in a flowing fluid stays constant. So, if pressure goes up, speed must go down to balance the energy. Lastly, let's talk about capillary action, or how high a liquid rises in a thin tube. As density increases, the height of the liquid column decreases. That's because heavier liquids need more force to rise, so they don't climb as high in the capillary tube. So, in summary, viscosity depends on density, but in opposite ways for liquids and gases. Pressure and velocity balance each other out, and denser liquids rise less in capillary tubes. These relationships help us understand how fluids behave in real-world situations, whether it's in nature, the human body, or engineering systems.
This project, we study three important properties of fluid, which is density, viscosity, and capillarity. From the density experiment, we learned that density shows how tightly packed the particles in a liquid are, which help explain why some liquid float while others sink. In the viscosity experiment, we observed how easily different liquids flow. Thicker liquids like dishwasher liquid took longer to move, showing high viscosity, while oil flow faster, showing low viscosity. The capillarity experiment showed how liquid rise in narrow tube. We found that the smaller the tube, the higher the liquid rise due to surface tension and the cohesive force between molecules.
Through these experiments, we uncovered several important relationships between fluid properties. One key finding was that liquids with higher density usually have higher viscosity. This means they flow more slowly because their molecules are more tightly packed, making movement harder. We also observed that as the density of a liquid increases, its height in a capillary tube decreases. Heavier liquids are pulled down more by gravity, which limits how high surface tension can lift them. Another interesting observation was that when pressure increases, fluid velocity tends to decrease. This supports Bernoulli's principle, which explains how fluids slow down in areas of higher pressure and speed up in areas of lower pressure. Overall, these experiments help us connect concepts like density, viscosity, pressure, and velocity, giving us a better understanding of how fluids behave in a variety of situations.
That's all from us. Thank you.